Hello my dear friends. Yesterday I have illustrated the method of false position for finding out the numerical solution to the algebraic equation or a transcendental equation. Complete method I have explained you. One illustrative example we have also done yesterday. Now in this lecture, second lecture, third lecture perhaps, we shall solve numerically, of course, one transcendental equation. The equation is x into log of x to the base 10 equal to 1.2. X into log of x to the base 10 equal to 1.2 by this method. So, this is not in the form, it is a transcendental equation, of course. Why? Why it is? Because it contains a logarithmic function. It is not of the form f of x equal to 0. So let me put it in the form of f of x equal to 0. Let solution. Now our f of x will be x into log of x to the base 10 minus 1.2 equal to 0. The given equation must be placed in the form of f of x equal to 0. So, this is the equation whose numerical solution is to be determined with the help of false position method. So, step 1, we determine 2 points capital A and B such that f of A into f of B is negative. So this is we usually do by trial and error method. This is log of x to the base 10. If I put x equal to 1, log of 1 is 0. So for what is f of 1 here? F of 1 is equal to 1 into log of 1 to the base 10 minus 1.2. That is good. Log of 1 is 0. So 1 into 0 is 0. So it is minus 1.2. It is negative, less than 0. So for x equal to 1, f of 1 is negative. Now, what is f of 2? 2 into log of 2 to the base 10 minus 1.2 equal to. Log of 2 is 0.30103. So 2 times 0.30103 minus 1.2. So, f of 2 is equal to minus 0.597940 minus 0. It is also negative. F of 1 is minus 1.2 negative, f of 2 is also negative. Now let me check what is f of 3. 3 into log of 3 to the base 10 minus 1.2. So 3 times log of 3 to the base 10 is 0.47712 minus 1.2. This comes out as 0.231364. 0 point. This is positive. F of 3 is positive, f of 2 is negative. That does mean the root lies between 2 and 3. Therefore, as a is equal to 2, b is equal to 3, f of 2 is equal to minus 0.597940 and f of 3 is 0.231364. Therefore, the root lies between this interval 2 and 3. Because f of 2 is negative, f of 3 is positive. So, from this value, this is the first step. We shall determine x1. Therefore, x1 is equal to, formula for x1 is a into f of b minus b into f of a divided by f of b minus f of a. Note this. A into f of b, that is equal to 2 into f of b is 0.231364 minus b into 3 into f of a is minus 0.597940 divided a into f of b minus b into f of a upon f of b minus f of a. This bracket minus this bracket. So 0.231364 minus. This is again negative. So negative. 0.597940. So value of x1 is 2.721014. Note this value. X1 is this. After finding out x1 by this formula, a into f of b minus b into f of a upon f of b minus f of a, we would be determining f of this x1. Again, f of x1, that is equal to f of 2.721014. Put value of x as this in this equation. 2.721014 into log of 2.721014 to the base 10 minus 1.2. That calculates as minus 0.0 minus 0.01710 17104, that is negative. F of 2.721014 is negative. Earlier, root was lying between 2 and 3. F of 2 was negative, f of 3 was positive. And now, in this interval for this point 2.721014, this f value of this is negative and f of 3 is positive. What does this mean? Therefore, the root now lies in 2.721014 and 3. I have still contracted this interval. Earlier it was from 2 to 3. Now it is from 2.72 approximately to 3. So, now take A is equal to this, B is equal to this. Now x2 is equal to, formula is A into f of B. A is 2.72104 into f of 3. F of 3 is 0.231364 minus B into f of A. B is equal to 3. F value of this just we have determined is minus 0.017104 divided by f of B minus f of A. This is f of B, 0.231364 minus, this is again negative, minus 0.017104. So value of x2 is now, on calculation, on this calculator, we get x2 is equal to 2.74021. 2.70, 2.74, 4021. 2.74021 x2. x1 was 2.7210. x2 is this. Now, again find out the f value of 2.74021. f of 2.74021 is equal to minus 0.00038904 minus 0.0003894. F value of it is very nearest to 0 perhaps. So it is negative. F value of this 2.74021 is negative. F of 3 is positive. What does it mean? It does mean that now the root lies between 2.74021 and 3. Thus, root lies between 2.74021 and 3. Again, because f value of this is negative, f value of 3 is, f of 3 is positive. Again take this value is equal to A, this value is equal to E, B. A and B taking A equal to this value 2.74021, B equal to 3, A into f of B minus B into f of A upon f of B minus f of A. This is A, this is f of A, this is B, and this is f of B. If we continue this process, we get x3 is equal to 2.740627. 2.740627. And its f value, f of this, f of x3 is 0.0001 11998. 0.0001198 x3. It is positive number. F of x3 is positive. And this value this x2 2.74021, it is negative. F value of 2.74021 is negative and F value of 2.740627 is positive. Therefore, root lies between 2.74021 and 2.740627. Because F value of this is negative and F value of this is positive, just we have seen 0.00011998. So this is value of x3. What does it mean? In both of these things, 2.74, in particular 2.740 is repeating. Here also 2.740 is repeating. It does mean that. And its F value is very small, too small. 0.0001198. Therefore, x equal to 2.740 is the approximate root of the given transcendental equation x into log of x to the base 10 minus 1.2 equal to 0, or x log x to the base 10 equal to 1.2. So answer is approximately equal to 2.740. That is the answer. So that is how this method has now been quite clear how to attempt the examples based on this. You need to remember how to spot the root. If one value is positive, another value is negative, then the root lies between that band, that interval. We go on contracting that interval step by step by this formula of x1 a into f of b minus b into f of a upon f of b minus f of a, successively stepwise. So that is how we solve examples method number 2, bisection method. I shall illustrate this method by taking directly an example. Method is very simple perhaps. Example is x cube minus x equal to 1. Example number 3. X cube minus x equal to 1. So by bisection method. Method of bisection. It is also called as a Bolzano's method. Bolzano's method of bisection. Now, this is an algebraic equation. It is not transcendental equation. It is purely an algebraic. F of x equal to, we would put it in the form of f of x equal to 0. So it is x cube minus x minus 1 equal to 0. What is f of 0? F of 0 is 0 minus 0 minus 1. It is negative. What is f of 1? F of 1 is 1 cube minus 1. 1 minus 1 is 0. It is minus 1. It is again negative. What is f of 2? 2 cube 8 minus 2, 6 minus 1, it is 5. This is positive now. So what we are getting here, f of 1, it is minus 1, it is negative, and f of 2, it is 5, it is positive. F of 1 is negative, f of 2 is positive. That does mean that the root lies between 1 and 2. Therefore, the root lies between 1 and 2. Now, we shall introduce the bisection strategy, bisection method. We shall bisect this interval. How? What is the midpoint of this interval? Midpoint is determined, say midpoint is x0. x0 is equal to 1 plus 2 divided by. So midpoint of this interval is 1.5. 3 by 2. F of 0. Okay. 1.5. x0 is 1.5. Okay. 3 by 2. So, this interval is something like this, 0 and 1, and this point is 1.5. This point is x0. Now, method, how it is method? So, it is 1 and 2. The center of this 1 and 2 is 1.5. F of 1 is negative. F of 2 is positive. What does this mean? No, what is f of 1.5? F of 1.5. 1.5 is 1.5. F of 0. F of 1.5 is 1.5 cube 1.5 cube minus 1.5 minus, so it is 27 by 8 minus 2.5. So it is P point 27 by 8. 8 3s are 24 3.375 minus 2.5. So it is positive. We just need its sign, don't need that value in this. F value of 3 by 2 or f of 1.5 is positive. F of 1, it is negative, and f of 1.5 is positive. What does it mean? The root now lies between 1 and 1.5. Root, therefore, the root lies between 1 and 1.5. Again, we shall bisect this interval. X0 was 1.5, 3 by 2. The bisection of this, it is now x1. x1 is equal to 1 plus 1.5 divided by 2. It is 1.25. Again, f value of this, f of 1.25. F of 1.25 is minus 0.29688. Minus 0.29688. Now, this was x2. x1 is 1.25. This is negative. F value of x1 is minus 0.29688. For this it is positive. 1.5. Just we have seen. It is positive. So now, the root lies in 1.25 and 1.5. Again, we shall bisect this interval. X2 is equal to 1.25 plus 1.5 divided by, so it is 1.3750. This is x2. And f value of this, f value of 1.3750, f of x2 is 0.22461. It is positive. This is positive and f of 1.25 is negative. For this value it is positive and for this it is negative. Therefore, the root lies in for 1.25 it is negative and for 1.3750 it is positive. Still the interval is contracting. Now x3 is midpoint of this, sum of this divided by 2. 1.25 plus 1.3750 divided by 2. And this comes out as 1.3125. And f value of this 0.0515, minus 0.0515, it is negative. F value of x3 is negative and F value of x2 is positive. x2 was 1.3750, therefore. Now the root lies in 1.3750. For this, F value was positive, and for this value x3, 1.3125, it is negative. Again, bisect this interval. The bisection of this is x4. x4 is sum of these two divided by 2. 1.3750 plus 1.3125 divided by 2, that's comes out at 1.3438. And its F value, f of x4, it is positive. F of 1.3125, it is negative. x3. F of 1.3125 is negative. And f of x4, it is positive. So root lies between x3 and x4. That is, root lies in 1.3125 and 1.3438. We go on bisecting this interval. So x5, 1.3125, 1.3438 is center point of this 1.3282. x5, 1.3125 plus 1.3438 divided by 2, that comes out as 1.3282. And F value of this is positive. F of x5, it is positive. For x4, it was positive. For x5, it is positive. But for x3, 1.3125 was negative. What does it mean? The root lies between 1.3125. Root lies in 1.3125 because F value of this is negative. And this is what? 1.328. We again take the bisection of this interval, midpoint of this interval, as x6 comes out as 1.3204. 1.3204, and F value of this is f of x6 minus 0.018 340. It is negative. So F value of x6 is negative and x5 is positive. So root lies between x5 and x6. x5 is 1.3282 and x6 is 1.3204. Root lies in this interval. Now x7 is sum of these two divided by 2 comes out as 1.3243. And its F value, F of x7, is put x7 equal to this value of x7 in this equation 1.3243 cube minus 1.3243 minus 1. It will be nearly 0 or nearest to 0, and that is the required numerical or approximate solution of the given purely algebraic equation x cube minus x minus 1 equal to 0, making use of the bisection method. So that is how we employ this method. Hope you will understand this after viewing seriously this video. Thank you very much. Thank you.